Hello everybody, welcome to video number 10. I hope you had a wonderful weekend. Can't wait to see you on Friday. Alrighty, you had homework on page 244. We went over all of those different properties of all the different quadrilaterals that we talked about. And remember the little flow chart? I'm going to kind of squeeze it on here. All right, we started quadrilaterals. A quadrilateral is a polygon, a closed figure with four sides. And then there are lots of different quadrilaterals that we're going to talk about. The first one is a parallelogram. And never write the word parallelogram, just draw a little parallelogram. A special parallelogram was a rectangle. A rectangle was a parallelogram with a right angle. And we ended up getting properties that said not only is there one, but all of the angles in a rectangle will end up being right angles. But by definition, a rectangle is a parallelogram with a right angle. We also talked about a rhombus. A rhombus is a parallelogram with all four sides congruent. And then we talked about a square. A square is both a rectangle and a rhombus. So the flow chart, everything flows down. If we prove something about a parallelogram, it's going to be true about a rhombus, a rectangle, and a square. If we prove something about a rectangle, it'll be true for not only rectangles, but squares. If we prove something about a rhombus, every rhombus, it will be true for also squares. Everything flows down. You can only go the direction of the arrows. And one other quadrilateral we talked about was a kite. A rhombus is a quadrilateral. A kite was a quadrilateral, not a parallelogram. It's a quadrilateral with two sets of disjoint sides congruent, or two sets of consecutive sides congruent. So these two sides and those two sides. Okay, well, since a square is a rhombus, all the sides are congruent. So in essence, these and these are congruent. So every square is also a kite. How about a rhombus? Is a rhombus a kite? The answer is yes. So there's this arrow also. Every rhombus is a kite, but you can't go that way. Not every kite. Every kite is a rhombus, but not every rhombus is a kite. Or does that make sense? No, it doesn't make sense. Which is which? Which way does it go? A kite is a four-sided figure with two sets of disjoint sets. So if I prove something about a kite, it will be true about a rhombus, but if I prove something about a rhombus, it won't go that way. So the arrow was right. So a square is everything. A square is a parallelogram, a rhombus, a kite, a rectangle. And then we talked about one other quadrilateral, a trapezoid. A trapezoid is a quadrilateral with one pair of opposite sides parallel. The parallel sides are called legs, are called bases, and the non-parallel sides are legs if it's an isosceles trapezoid. An isosceles trapezoid, the non-parallel sides are congruent. The bases are the parallel sides, The two congruent sides are called legs. The two angles at the bottom are called base angles, lower base angles. The two angles at top are called the upper base angles. And again, I've got this drawn with the longer side on the bottom. You could flip it over. The bottom could be the smaller of the two sides. It doesn't matter, the smaller of the two parallel sides. But a trapezoid is any quadrilateral with one set of opposite sides parallel. If the non-parallel sides happen to be congruent, then you have what is called an isosceles trapezoid. And we talked about a zillion different properties. They're all listed for you in the book that dealt with all of these different quadrilaterals and special quadrilaterals. And I told you when using, when you're asked to prove, if you were asked to prove that something is, or if you're asked to prove something and you're given that it is a parallelogram, if you use any of the properties as a reason, you don't have to write it all out. Just go property of parallelograms, etc. I'll explain that more when we get to a proof where we do that. Alrighty, but you had homework on page 244. The number first problem was a proof. And they gave you this figure. And this was AB, CD, and E and F. And they gave you that this was a parallelogram with AE congruent to CF, and they wanted you to prove that DE is congruent to EB, or excuse me, FB. Well, let's take a second. You have two ways to attack this. I can prove this little triangle and that little triangle are congruent. DE and FB would be corresponding parts of congruent triangles if I could do that. Or I could prove these two triangles congruent. Triangle DEC and BFA. If I could do that, same thing. DE and FB would be corresponding parts of congruent triangles. Because of this given, I'm going to get the two little triangles congruent first, and then I'll show you how to get the other ones. So, statement 1, given. Statement 2, I know that by properties of parallelograms, not only is AD congruent to BC, AD is parallel to BC. Two of the properties of parallelograms. And again, that's what I mean. If you use this in a proof, you don't need to write all that stuff out. Just go property of parallelogram. Again, never write the word parallelogram. Just draw a little parallelogram looking figure. So now I've got this side congruent to that side, and they're parallel. Since these two sides are parallel, using AC as a transversal, this angle, call it 1, and that angle 2 are alternate interior angles. Therefore, that angle and that angle are congruent. Alternate interior angles of parallel lines are congruent. They're parallel right there, property of parallelograms, and that gives me enough to say that triangle AED is congruent to triangle BFC by SAS, side angle side, side angle 1 side. And since they're congruent, then corresponding parts, DE and FB, or BF, are congruent. They are corresponding parts of congruent triangles, therefore they're congruent. CPCTC. Hopefully everybody follows that. You could have done the two big triangles. It just involved one extra step, addition property. With the two big triangles, you're going to essentially do the same same thing. You're going to say DC is parallel to AB and congruent, property of parallelograms. You're going to get this angle and that angle congruent. They're alternate interior angles. You do need to put it in the proof, say EF is congruent to itself, reflexive, and then by addition, since AE is congruent to FC, you're going to add FE to those two parts, and that would give you AF congruent to CE by addition, and then you would have those two triangles congruent by SAS. DE, and FB congruent by corresponding parts. Whichever way you happen to see it, that's fine, if you did it either one of those two ways. I want to skip ahead to problem number 15. Because if you look at problem number 15, it's the exact same figure with the exact same given. Problem number 15. So skip ahead, please. It's labeled it differently, a little bit differently. But it is actually it's even labeled the same way. Only they made this F and that E. And the question in this, or the problem here said, prove that these two line segments are parallel. So it is the identical proof, and I'm going to leave it labeled this way. They had E and F in different spots. You're going to, again, do exactly the same thing we just did. You're going to prove these two little triangles congruent or the two big ones congruent. It doesn't matter. But since we've got the little ones here, let's leave it. So once we get these two little triangles congruent, instead of saying that's congruent to that, I am going to say angle 3 and angle 4 are congruent. CPCTC. And with respect to the two little line segments, using AC as a transversal, these are alternate exterior angles. And again, if you don't see it, pull them out. Here, if you extend it, here's D, E, and here's F, B. And the transversal is looks like this. Here's angle 3. Here's angle 4. And once we get them congruent, with respect to these two lines, using that as the transversal, they are alternate exterior angles. If alternate exterior angles are congruent, then lines are parallel. So I could say, again, they had that as F and that as E, doesn't matter. DE is parallel to BF. So problem number 15. Problem number 15, basically the same exact problem as the first one, problem number 4. You had to go through the same exact steps, get triangles congruent, get angles of those triangles congruent by corresponding parts, and then you had either alternate exterior, or if you wanted to take the time, you could have said this angle and that angle are congruent. By supplement, you'd say these two angles are supplementary to 3 and 4. Since 3 and 4 are congruent, then those two angles would be congruent by supplement theorem, and then you would have alternate interior angles congruent. I told you from day one, as you get more and more information, proof work, you're going to get more and more possible ways of approaching the same proof, and we might get a proof where all 9 of you in class do it differently, and all 9 of you will do it correctly. Okay, 15. Number 5. Number 5, you were given. Number 5, you were given that this figure is a parallelogram, a WSTV. And you were given that WS is x plus 5. You were given that WV is x plus 9. And you were told that VT is 2x plus 1. And in problem 5, this is not a proof, it's a find. Whenever you see the word find, it's numerical. They said find the perimeter of the figure. Well, since they gave you, and again, they didn't write the word out, they just drew the little parallelogram. Given parallelogram WSTV, so I know this is a parallelogram, so all of the properties of parallelograms hold. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary. All those properties of parallelograms hold true, which tells me this side and this side have to be congruent. Therefore, x plus 5 is equal to 2x plus 1. Subtract x from both sides. Subtract 1 from both sides, and you get x is equal to 4. Perfectly correct. Don't stop there. The question didn't say find x. You had to find x in order to get the final answer, which was the perimeter of this figure. Well, if x is 4, that means this side is 9, which makes that side 9. And this side is 13, which makes that side 13. Therefore, the perimeter is equal to 2 times 9, 18, plus 2 times 13, which is 26. 18 plus 26 is 44. And there's your answer, your final answer. The perimeter is 44. Bada boom, bada bing. Okay? And as always, if you don't understand, pause the tape or run it back. Or if you still are clueless, write it down, ask it on Friday, or give me a call or shoot me an email. Okay? Next problem. Number 6. Again, you're given a parallelogram. So you're told this figure is a parallelogram, ABCD. So all the properties of parallelograms hold. They said the measure of angle A is x, and the measure of angle D is 3x minus 4. And they said find the measure of angles D and C. Alrighty, properties of parallelograms. Any two consecutive angles in a parallelogram are supplementary. They're interior angles on the same side of a transversal because these two sides are parallel, DC and AB. Using AD as a transversal, they're interior angles on the same side of the transversal. Therefore, they're supplementary, which means their sum is equal to 180. So I get 4x is equal to 184. X, therefore, is 46. Again, don't stop one step short. That is correct, but they didn't say just solve for x. They said find the measure of angles D and C. All right, well, if this is 46, I know that's 46. Opposite angles of a parallelogram are congruent. And consecutive angles are supplementary. The supplement of 46 is 134, or just plug 46 in. 3 times 46 is 138, minus 4 is 134. Okay? Everybody, I hope, got that or understands it now. Number 6. The next problem, number 7. Again, another find problem. They give you an isosceles trapezoid, and they told you it was E, G, H, E, F. G, H, E, and F, and they had the diagonals drawn in, and it said that the congruent sides are these two, and they told you that EJ was x plus 5, this being J, this is x plus 5, and they told you that JG was 2x minus 1, so this is 2x minus 1, and they told you that HF, this whole diagonal, is 13. Well, one of the properties of isosceles trapezoids was the diagonals are congruent. Diagonals of an isosceles trapezoid are congruent. Therefore, x plus 5 plus 2x minus 1 is going to equal 13 because the two are congruent, and they gave you HF. The whole thing was 13. So there's your equation, and then just solve. And again, be careful. They didn't ask you for x. They wanted the line segments. So I've got x plus 2x is 3x. 5 minus 1 is plus 4 equals 13. So 3x is equal to 9. X equals 3. Okay, if you stop there, you're absolutely totally correct to this point, but that wasn't the question. They wanted EJ. Well, EJ is equal to x plus 5, which is 8. They wanted JG, I believe, which is 2 times 3, 6. 6 minus 1 equals 5. And they wanted HJ. I'm not sure if I told you this or not, but when you draw the diagonals in an isosceles trapezoid only, they don't bisect one another, but they cut each other into congruent pieces. In other words, this piece and that piece will be the same. This piece and that piece will always be the same. They don't bisect one another. If the diagonals bisect one another, you're not going to have a trapezoid. We can prove if that happens, if the diagonals of a quadrilateral bisect one another, it has to be a parallelogram. But this one, they told you it was a trapezoid. So if that's 8 and that's 5, this is going to be 8, and this piece is also going to be 5. So EJ is 8. FJ, which they didn't ask for, is also 8. HJ and JG are both 5. Okay? Hopefully you understand this one now. Number 11, numerical problem, kite. All right, they gave you kite, K-I-T-E, and they told you that point P, and in this kite, they told you that this angle is 5x minus 10, and they told you that this piece is 6x. All right, properties of kites. The diagonals of a kite are perpendicular, and again, since it's a kite, that and that are congruent, that and that are congruent. Since I is equidistant from K and T, and E is equidistant from K and T, I know that this is the perpendicular bisector of KT, i.e. perpendicularly bisects the smaller diagonal. So I know that this piece and that piece are the same. I also know that these are right angles. And they told you that 5x minus 10 is not the side, it's the angle. So angle IPT is equal to 5x minus 10. And what else is it? It's a right angle. So there's your equation. 90 is equal to 5x minus 10. Add 10, you get 100 is equal to 5x. So x is 20. Again, please don't stop one step short. You need x in order to find the answers. They wanted to know how long is KT. KT. Well, it's the KT, remember, is perpendicularly bisected by IE. Therefore, this is also 6x. So KT is equal to 12x, which is 12 times 20, or 240 whatever units. Hopefully everybody followed that. Diagonals of a kite. One will always perpendicularly bisect the other, and it's generally the longer one. Or again, just use the perpendicular bisector theorem. These two pieces are equal, making I equidistant from K and T. These two pieces are congruent, therefore E is equidistant from K and T. And the perpendicular bisector theorem said if you connect those 2 points, the line segment, in this case IE, will perpendicularly bisect the other segment, KT. Okay? Hopefully everybody's gotten that. All right, we did the 15. The next one is 17, which was a proof. And in 17, this one's a little longer. They gave you, and again, I'm not going to write it all. It's right there in the book for you. They gave you the isosceles trapezoid, RSTV, and that's point A. And they said that these are the legs, and they said that prove that triangle ARS is isosceles. To prove that a triangle is isosceles, you have two options. You can either prove that you have two angles congruent. So if I could prove that this little bottom angle and that little angle are congruent, then I would have an isosceles trapezoid, or you have to prove the two sides, AR and AS, are congruent. Either way, it's up to you. I think it's going to probably be easier to prove angles congruent. So I'm going to call that angle 1 and that angle 2. All right, properties of isosceles trapezoids are coming into play here in a second. If you don't see it, there's a lot of ways to go about this one, and there's also a lot of triangles in this figure that are overlapping. And remember, I told you if you can't see it, maybe pull them apart. And here's what I'm going to do. I'm going to pull them apart. VRS, and they don't have to be accurate. It's just a visual aid. And then this triangle, TSR. Angle 2, this is angle 1. Angle 2 was this angle. So if I could prove these two triangles congruent, that would give me angle 1 and angle 2. And what I've got so far is that. I know that you were told that these were the congruent sides, TS and VR. So I know that RS is congruent to itself, reflexive. It's in both triangles. I also know that with respect to the original isosceles trapezoid, VS VS is a diagonal TR, or excuse me, this is T. This is T. TR is a diagonal, and I know that diagonals of an isosceles trapezoid are congruent. Therefore, VS is congruent to TR. Property of isosceles trapezoids or diagonals of an isosceles trapezoid congruent. You can write it either way you want. And that gives me these two triangles congruent, side, 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 side. So I've got triangle RSV is congruent to triangle SRT. Side, 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 which makes angle 1 congruent to angle 2, CPCTC, and I'm done. If angle 1 is congruent to angle 2, that means this little triangle, the bottom triangle, forget all this other stuff, triangle SARS is isosceles. Two angles congruent. To get a triangle isosceles, you would have to have either two angles or two sides congruent. I got two angles congruent. And bada boom, bada bing. There are other ways to do this problem. I think this is probably the quickest, easiest, no fuss, no muss way. Hopefully you see it now if you did not get it. And the next couple problems are numerical. The next one was number 19. Number 19, you were given a parallelogram again. Parallelogram KPOM. And you were told that angle M is x plus 3y. You were told that angle O is x minus 4. And you were told that angle P is 4y minus 8. Alrighty, since I've got two variables, chances are that I am going to get simultaneous equations. Two equations in two variables. And there's there's at least three different equations that I can set up here. I know these two are congruent. They're opposite angles of a parallelogram. I know that these two are supplements. Property of parallelograms, consecutive angles are supplements. That's the second equation. Or I could go that way and say that they're supplements. And it doesn't matter. You only need two of the three. You don't need all three. So depending upon how you wanted to do it, you could have simply done the following. I'm going to use these two. I know that x plus 3y is equal to x minus 4. And I chose that because plus x minus 4 equals 180. Consecutive angles are supplements. And since I've got two equations or two variables, I'm going to simply leave the variables on one side for the time being. So this becomes 2x plus 3y is equal to, add 4, you get 184. So there's your first equation in two variables. And then again, I can either say these two add up to 180 because they're consecutive angles of a parallelogram, or I could say these two are equal because they're opposite angles of a parallelogram. So I'm going to use that one. And it doesn't matter, you could have used these two and added up, they equal 180. It's up to you. But I do also know that x plus 3y is equal to 4y minus 8. So, since we're doing simultaneous equations, get everything on one side. Subtract 4y, you get x minus y is equal to negative 8. So I now have two equations in the same two variables. And simultaneous equations you can do by addition-subtraction method or by substitution method. Substitution method, you take one equation and solve it for one of the letters, and then you plug that back in to the other equation, or you add or subtract the two equations or multiples of the two equations from one another to eliminate a variable. Doesn't matter which way you do it. I'm going to do it by addition subtraction. If I add y to both sides, I get x equals y minus 8. And then I'm going to take this value for x and substitute it in the first equation. If you use the substitution method, you solve one equation for one letter, and then you take that value and plug it back in the other equation. If you plug it back in the equation you just started with, you're going to just get negative 8 equals negative 8. Everything will cancel each other out. So you plug this value for x here. So you get 2 times y minus 8 plus 3y is equal to 184. Okay? Multiply through, you get 2y minus 16 plus 3y equals 184. So you get 5y. I'm sorry, I'm sloppy. Add 16 is equal to 200. Divide by 5, and you have now solved for y. Y is equal to 40. So y equals 40. Take this value for y and plug it back in either of your two original equations. I know that x minus 40 is equal to negative 8. Add 40, and that means x is equal to 32. Again, plug a 40 right here. X minus 40, add 40, and you get negative 8 plus 40, which is positive 32 equals x. Now, again, if you stop there, that's correct, but that wasn't the question. The question was, find the measure of angle K. The measure of angle K. K and O are opposite angles. They are congruent. So the measure of angle K is equal to x minus 4. X was 32. X is equal to 28. Therefore, the measure of angle K is 28 degrees. Again, don't stop there. The question was find that angle. These two angles are congruent. Therefore, I know that angle K is going to just be x minus 4. Substitute in 32 for x. 32 minus 4 is 28. And you are done with that. I told you, simultaneous equations and quadratic equations you have to be fairly comfortable with. They're going to pop up all year. Hopefully you understand this now. And the last problem, number 21, again, numerical. It said you have a kite. And they told you that you've got 6 minus 2x. You've got 2x plus 30. And the side is 20 plus 3x. All right, now, the thing they didn't tell you was, there's two ways to do this. You could say these two sides are congruent, and these two. Or you could say these two sides are congruent and these two are. So there's two totally different kites here, depending upon which sides you set equal to each other. That's why they said work this out two ways and see which pairs of sides are congruent. So you've got either 2x plus 30 equaling 20 plus 3x, or these two sides are congruent. 2x plus 30 is equal to 6 minus 2x. Again, it's a kite, so a kite means two sets of consecutive sides congruent. So you could have these two congruent and these two, or it could go this way. These two congruent and these two. And that's what this takes into consideration. The first one I said this and that are congruent. The second one I said these two are the congruent sides. So solving, subtract 20 from both sides, subtract 2x, and you get x equals 10, if it's that way. Or, if you do it this way, add 2x to both sides, you get 4x, subtract 30 equals negative 24, so x would equal negative 6. Unless I did that wrong. No, I did it right. Now, don't do this. Please don't say, oh, can't do it. That doesn't work because you'll get a negative side. Well, remember, x is not the measure of the side. It's used to find the measure of a side. So don't eliminate that yet. As a matter of fact, we're not going to eliminate. If x equals 10, then side KE would be 6 minus 20, which would be negative 14. Now I can say that can't possibly work. That can't possibly work. Therefore, x cannot equal 10 because it would give me a negative side. You cannot have a negative side in a geometric figure. So those of you that eliminated negative 6 just because it was negative, as it turns out, the positive value doesn't work. Hopefully the negative will. All right? If x equals negative 6, KE is 6 minus 2 times negative 6, which is 6 plus 12, or 18. All right? Which would make KI 2 times negative 6 plus 30. Negative 12 plus 30 is 18. And IT would equal 20 plus 3 times negative 6, which is 20 minus 18, or 2. Therefore, these are the only two sides that could be congruent. These two would be congruent, and these two would be congruent. Okay? So these would both be, it's this 18 and 18. So your kite is going to actually, if you actually were to draw this one out, it would be a really little, real skinny thing like this. Where these are 18 and 18, and these two sides would both be 2 and 2. So in this problem, as it worked, the positive value that you get for x actually does not work in the problem. So do not automatically eliminate a negative answer when you are solving a problem if the value that you're looking at is not the actual answer, but it is used to get the answer. When you plug a negative 6 back in for x, you get positive values for the side lengths. When you plug this positive value for x in here, you get a negative number, and you can't have a negative side in a polygon. So hopefully that makes sense to everybody. Again, if you have questions, contact me or just write it down, and I'll be happy to answer it on Friday. That was your homework. Alrighty, so you have at least 50 different properties of parallelograms, rhombuses, rectangles, etc. We had all those properties of various quadrilaterals. Today what we're going to do is we're going to get 5 ways of proving that a particular figure is a parallelogram. The first one is easy, the definition. The definition of a parallelogram was a quadrilateral with both sets of opposite sides parallel. So somehow, if you can get into a quadrilateral and you can show that these two sides and these two sides are parallel, you have both sets of opposite sides parallel, you have satisfied the definition of parallelogram, and you can say whatever this is, ABCD. ABCD is a parallelogram by definition. Okay? That's the easy one. The next way, if both pairs of opposite sides are congruent. The only way you can have a quadrilateral with both sets of opposite sides congruent is if it's a parallelogram. So if I started with something like this, A, B, C, D. Well, I've only got one way to prove that a figure is a parallelogram, the definition. So if I could show that this somehow, if I can show that not only are they congruent, but they're parallel, then I fulfill the definition, and then I would have proved this. And I'm not going to write this up formally. All you have to do is draw a diagonal. Either one. Draw a diagonal BD. Line postulate. BD is congruent to itself. These two triangles, therefore, are congruent by side, side, side. And since they're congruent, call this angle 1, 2, 3, and 4. Angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. They are corresponding parts of congruent triangles. Remember, they're opposite congruent sides. Angle 4 is opposite the double tick. Angle 2 is opposite the double tick. Angle 1 is opposite the single tick. Angle 3 is opposite the single tick side. All right, now, with respect to these two sides, using that as a transversal, 3 and 1 are alternate interior angles, which would make sides AB and CD not only congruent, but parallel. If alternate interior angles are congruent, lines are parallel. With respect to BC and AD, using that as a transversal, 2 and 4 are alternate interior angles. They're congruent. Therefore, those two sides are parallel. So now I have a four-sided figure with both sets of opposite sides parallel. So it now fits the definition, and I am done. I've proved this works. So I now have 2 ways to prove a figure is a parallelogram. The definition, get both sets of opposite sides congruent, or get both sets of opposite sides, both sets of opposite sides parallel is the definition, or both sets of opposite sides congruent. A third method, if one pair if you ever get a figure that looks like this, so side AD is not only parallel to BC, but they are congruent. I have one pair of opposite sides, both congruent and parallel. So in order to prove this one, I can use either of the ones above it. I can either fulfill the definition, get the other two sides parallel, or I can use this, get the other two sides congruent. And again, This one, what you want to do is draw a diagonal. And I can prove that I know that since these are parallel, I know that's congruent to that. Alternate interior angles. AC is congruent to itself, reflexive. So this triangle and that triangle are congruent by side angle side, side angle side, common side. Since that's the case, that means corresponding parts CD and AB are congruent, making that a parallelogram by statement 2. Both sets of opposite sides are congruent. Or I also know this angle and that angle are congruent, corresponding parts, which would make these two sides parallel. If alternate interior angles are congruent, lines are parallel, and then I would have the definition of parallelogram. So I now have 3 ways to prove a figure is a parallelogram. Both sets of opposite sides parallel, definition. Both sets of opposite sides congruent, or one pair of opposite sides both congruent and parallel. Number 4, if the diagonals of a quadrilateral bisect one another. So if I've got this quadrilateral and I draw those in, and that are congruent, that and that are congruent. They bisect one another. The only way that that works is if this figure, whatever you label it, I can prove that ABCD is a parallelogram. The way you do this one, that angle is congruent to that. V8, there's a whole bunch of ways. VAT, making this triangle and that triangle congruent by side angle side, side angle side. Since that's the case, that makes this side congruent to that side. And it makes this angle congruent to that angle. They are corresponding angles. They are corresponding parts of congruent triangles. Opposite the single tick, opposite the single tick. And with respect to the top and bottom, those are alternate interior angles. Therefore, BC is parallel to AD, and we have just proved one pair of opposite sides are not only congruent, but parallel. Therefore, by 3, we have proved 4. So a 4th way to get a quadrilateral, a parallelogram, prove that the diagonals bisect one another. In any quadrilateral, in any 4-sided figure, I mentioned this in one of the homework problems, in any 4-sided figure, if the diagonals bisect one another, the figure must be a parallelogram. And the last way, number 5, we can't prove yet. We're going to take this one as a postulate. We have to know about the sum of the angles in a quadrilateral before we can prove this one. 5 says if I have a figure where both sets of opposite side angles are congruent. Again, excuse the drawing. It's a cruddy drawing. But here, and again, we can't prove this one yet. We need to know about the sum of the angles in a quadrilateral first. So I'll come back and prove this one for you later. But if you ever have a 4-sided figure where both sets of opposite angles are congruent, this figure must be a parallelogram. And for right now, we're going to accept this as a postulate. So you now have 5 ways to prove a polygon is a special quadrilateral, a parallelogram, and you can use any one of those 5. Fulfill the definition, get both sets of opposite sides parallel. You can get both sets of opposite sides congruent. It's got to be a parallelogram. If you get one set of opposite sides both parallel and congruent, it must be a parallelogram. If you have a quadrilateral with the diagonals drawn in and they bisect one another, it must be a parallelogram. And 5, if both sets of opposite angles are congruent, it must be a parallelogram. And believe it or not, that is all I want to talk about today. So for Friday, please. And again, any questions, please write them down or email or call me. Page 251. One, 5, 6, 9, 10, 11, and 17. 10, 11, 12, and 17. Okay. Alrighty. I look forward to seeing you on Friday. Adios.